Okay, welcome. We are going to be finding a limit of L and then use the epsilon delta definition to prove that the L is the limit. So, without further ado, given this is a weird one that sometimes students get a little confused about. It's not a hard function. What we have here is a function of negative 1. So if we graph this, this is, yes, a horizontal line. It's a horizontal line. I'll make that right here, passing through negative 1. So y equaling negative 1. We are trying to figure out what is the value going to be as you get closer and closer to 2. All right, so if you plug this into here, you realize this function is continuous. And then as we get closer and closer to 2, it appears from the right and left side, we are approaching a value of negative 1. Now, according to the epsilon delta definition, what we have is a delta, which has to be greater than 0, all right, such that we have x minus our c value is 2 in this case, which is less than delta. And then we have a epsilon, which is greater than 0 as well, where we take our limit, take our function, all right, in this case it's negative 1, and we subtract our limit, but in this case it's going to be negative 1 as well, and that has to be less than epsilon. All right, now, when we have this, this is where the weird part comes in, is that as we prove this right here, we realize that we have negative 1 plus 1 epsilon. Well, this turns to be 0 in the epsilon. So basically, what is this saying? Well, this is saying that any epsilon greater than 0 we can use, all right, for this. So that means epsilon, you can have any value farther away from here as you plug this in. So if you wanted to figure out, okay, where's this going to be, I plug in a value way over here, okay, anything greater than 0, and I plug that in, all right, anything over here. So epsilon, this distance from L, all right, remember this is what L is, and this epsilon right there, and the epsilon right there, all right, to the right and left of L, let me go plus L, let me go plus L, okay. That will generate a value, all right, which will be delta units away. Well, on this side, delta units away. Well, what does delta have to be? Okay, what does delta have to be? You can already get that. Well, if you have this, well, if you're going here, well, you realize that delta is going to be the same thing as epsilon. Because of this weird function where it's just a constant, any delta that is greater than 0 will generate a limit which will be the same thing, all right? Because epsilon is greater than 0, delta that just has to be greater than 0. Hence, any value for delta greater than 0 will give us a limit of negative 1, which will give us a epsilon greater than 0. So this is what epsilon and delta are for this definition. Yeah, that was tricky, right? Because this is a horizontal line, any value you plug in is always going to equal negative 1. So it doesn't matter how far you're away from 2, in this case 2, we will always get a value, negative 1, which will give us a limit. All right, that is approaching there. So that was one that I just wanted to show because many of my students always get confused by this one, and it's kind of tricky for them. So I hope this helps you out with epsilon delta definition of a constant. But there we have it, and good luck and God bless on the remaining of the rest of your problems.